Hello everybody and welcome to our webinar Optimize Your Embedded C Code using automated code inspection with Codee. I'm very happy today to do this webinar together with Manuel. Manuel is CEO and co-founder of the company Apentra, or also named Codee. It's a company in Spain and they have a great tool for performance analysis and increasing performance. At the end of the webinar, Ulysses will give you a live presentation of the tool Codee. And my name is Klaus. I'm CEO and co-founder of Verifysoft technology. We are distributor for Codee tools in German-speaking countries. And I'm very happy to do this webinar together with our friends from Spain. So some words about Verifysoft. We are for 21 years in the market already. We have own tools and we are in addition, we are distributor for a couple of other companies. One of them is Codee, and in addition to the tools, we do also seminars. We have over 750 satisfied customers in 43 countries now, everywhere where software quality is very important. There we have a lot of customers. And our main tool is a code coverage analyzer. This is a tool to show you which part of your code you have tested and which part is not yet tested. It analyzes a very high coverage level and can be used in safety critical projects. TÜV certified. Then we have another static analysis tool from CodeSecure, the tool CodeSonar. This is checking for bugs. These are reviewing coding standards, software matrix, and so on. And we have, in addition, we have a tool Imagix 4D. This is a tool which can help you when you have software where you don't know exactly what is happening around. So to make some reverse engineering and to better understand your code. The topic today is Codee. This is a tool to optimize the performance of applications. And one important thing for the people from German-speaking countries here is we have around these topics. We have a code coverage day and on 24th of September in Mannheim, and we have 3 days for static code analysis on the road. Manuel from Codee will also be there and make a presentation. This should be enough for my introduction. Let's give over to Manuel now. Thank you.
Klaus, thank you. Thank you very much for...
Yeah, you're welcome. It's a pleasure. It's a pleasure.
It's really a pleasure to organize this webinar with you and also to have the opportunity to share in person this static analysis on the road. The purpose today is to present you Codee, which is a new platform for source code analysis that will help you to and will guide you through the process of optimizing your embedded C++ code. Essentially, Codee is the legal name of the company is Apentra Solutions, but you will recognize us as Codee. Codee is the brand name, the commercial name. We are a deep tech company headquartered in Spain, north of Spain, in a small city called Coruña. And we are helping many organizations worldwide by empowering developers in the process of modernization and optimization of C++ and Fortran software. And we have been already more than 7-8 years in the market, and we have been working with reference corporate and institutional customers in markets like the ones you see here: electronics, healthcare, renewable energies, automotive, and high-performance computing, where performance is the king, I would say, and also in locations like the US, Israel, Australia, Saudi Arabia, and across Europe. So we are used to work with many companies worldwide and show them the benefits and help them with the adoption of the Codee software. Let me try to explain which are the main drivers why you should consider optimizing embedded C++ code. The first thing to understand that is important is that performance optimization is not, I would say, a one-step process. It's a long, complex, and time-consuming process that typically requires the developers to understand and have expertise in performance optimization techniques. So having understood this, typically in embedded systems, getting a 5 to 10% performance boost is typically a huge improvement. This, of course, depends on the type of hardware you are using in your system, like from a microcontroller all the way up to a server class processor. This will, as we will see later, this will have an impact on the actual performance gain that you can obtain out of your code. Also, another important point to understand is that compilers are the tool that we typically trust to generate code that runs efficiently on the target environment. But compilers do not implement all the potential performance optimization techniques that you can apply to your code. So when it comes to embedded C++ code, it is typically the developer who must manually implement performance optimization techniques that are not provided by the compilers. And compilers there is a wide variety of compilers in the market, and with very different performance optimization capabilities. So switching from one hardware to another, from one compiler to another, or even from one compiler version to another, can provide very different performance optimization or performance boost to your code. So this is definitely something that you need to consider. So I would say that the key value proposition of Codee in this long, complex, and time-consuming process is that Codee provides a systematic and more predictable approach to performance optimization that favors maintainability, readability, and overall, it empowers developers with performance optimization skills and also simplifies the software development process for optimization of embedded C++ code. So having understood this, it is also important to understand the nature of performance optimization. When it comes to using a tool that oriented to performance, you cannot expect any tool, neither a profiler, not even an expert developer specialized in performance, not even a tool like Codee, to guarantee that you will get a given performance boost. The reason for this is that performance depends on many other things beyond the source code itself. Depends on the hardware, depends on the compiler, the operating system, and many other libraries or pieces of the software development environment. Okay, so having understood this, what we will see is that Codee will provide capabilities and features that will help you to empower your developers to reduce the effort required to go through this process of performance optimization in embedded C++. To give you some results of what you can expect at the end of this process, here we are seeing an example from real-time software where in real-time performance is always very, very important. And here we have chosen the embed-TLS cryptographic library, and using the GNU compiler version 8.4 that is bundled within the QNX 7.1 software development kit, we can see that by using Codee, you can speed up accelerate the runtime of the AES XTS encryption algorithm by a 1.3 factor. This is really, really big improvement, and both targeting running on x86 hardware and ARM hardware, which is adopted and very widely adopted in embedded software community. So how do you get this performance boost in embedded TLS? Essentially, Codee is taking advantage of Codee recommendations for single core optimizations, in particular for vectorization and syndicization primitives available and implemented in the processor or in the microcontroller hardware. So the benefits here from vectorization are threefold: is higher speed, but also very important, a smaller core size, taking advantage of vector instructions, and also energy savings, taking advantage of the execution in the vector pipeline of implemented in the processor. To introduce the capabilities of the Codee tool, let's try to land the concepts of what you need to optimize your code and why optimizing embedded C++ code is typically so hard. The key is that you need to write embedded C++ code that is, let's say, environment aware. And this means that you need to write your source code taking into consideration the type of hardware you are using. ARM, x86, vector instructions, specialized instructions, cache memory, all of this is part of the hardware, and you need to write in a hardware-aware manner. As we said, the compiler, different compilers provide different performance optimization capabilities, and even between compiler versions. So definitely, you need to write knowing what your compiler is doing and what your compiler is missing or is not doing to optimize your code. And of course, you need to run in the scope of an operating system. For instance, if you are running or developing real-time software, real-time operating systems like QNX we mentioned before will provide you scheduling capabilities, but these scheduling capabilities will not interfere, will be complementary to single core optimization that you can actually implement in your code. So in the end, optimizing your source code, you must do it by writing it in a environment-aware manner. So in the end, to go through this long process, we need to provide tools like Codee that empower developers and enable simplifying the software development process. So, so we know what we need to do to optimize the code, that is, writing a compile in an environment-aware manner. But the question is, how do we do it? How, where in the code we need to make modifications, or we need to do fine-tuning to actually take advantage of the potential performance that I have in my environment. This is where the open catalog of Codee comes into play. Codee, during these years, we have been creating and curating the first open catalog of best practices for modernization and optimization of code, where you can see all of the rules, more than 80 at this moment, that have been automated in Codee, and all of them oriented to modernization and optimization of code. And you can see for each of them that they, if they apply to C, C++ or Fortran, and even if the tool is providing auto-fixes, so the capability of Codee to actually modify your source code to implement the modification. And each of these rules essentially comes with information or documentation to empower developers so that they understand what is the issue, what is the action, the remediation action that needs to be implemented, why it is important, and very important, illustrated with examples, very simple examples to understand the concept of what you need to do in order to take advantage of a given performance optimization rule. So we know what we need to do. With the open catalog, we know how to do it. But what we finally need is a tool like Codee that automates the process of scanning hundreds of thousands or even millions of lines of code in seconds or minutes and produce a report where you know for each function, each loop, and each file of your source code, what rules of the open catalog actually apply to your code. This level of automation is what provides a huge amount of savings in time to the software development teams, okay? Similar to the benefits of shifting left, security, shifting left, compliance with coding standards. Here we are, for the first time, also shifting left optimization of embedded C, C++ code. So in this regard, the tool, what you will see the demonstration of Codee as a tool, is that what you will see, it will provide a static code analysis to understand or pinpoint which rules of the open catalog available in the web and released under the Apache license, so knowledge given for free to the community and developed with a community of experts. But in the static analysis tool, you will have the reports needed to actually understand what's going on in your own code. And also, whenever auto-fixes are available, Codee will point out the existence of that auto-fixes. Also, the tool, Codee, is designed from day one to be installed on-prem, and also to be integrated in CI/CD frameworks, which are essential for high productivity software development teams. And Codee includes also a wide variety of reports, and especially reports like technical depth and ROI estimation intended for developers and also for team leaders and managers to understand the impact of Codee tool on their actual code base on their organization. So let me go quickly through the sequence of Codee command line invocations that you will later see in the demonstration conducted by my colleague Ulysses. So we have standardized the workflow or the sequence of commands that you will need to run using Codee. So our suggestion is that you start running the Codee technical debt report. The technical debt report will provide you one single number, the technical debt score, that sums all the checkers that Codee has found in your source code. And also will measure the number of files, functions, and loops of your code that are affected by the rules found in your code. Okay? And also you will have a technical debt score available for each compilation unit or for each file. So this is the landing analysis. So understanding the amount of issues found by Codee and the portion of your code affected by those issues. The second, after that, the second invocation that we typically recommend is this, what we call the screening and ranking report. In the technical debt, we know how many issues Codee has found, let's say 1,000. But the second question is, which out of the catalog, which rules of the catalog have been found? And also, how many times these ones have been found? And where should I start? What are the checkers that I should give more priority, higher priority, because they probably will have a higher impact on optimization or performance of the code, and those that should be lower priority for my team because they are less likely to produce performance optimization reports. One important thing to note is that all the checkers automated by Codee and published in the catalog are motivated by real-world loops, real-world examples, where we have seen a performance boost. So this doesn't mean that this performance boost will apply to your code, but at least you know for sure that all the checkers reported by Codee are motivated by real-world examples where we have observed and measured performance boost. So here in this screening and ranking, what you see is exactly this, a ranking of all the checkers that Codee has found in your code, and you should typically go top-down. Start with the first one, understand what's going on by looking at the documentation available in the open catalog, understand if it makes sense, try to fix it in your code, and once you fix it, recompile and measure the performance, the potential performance gain you have obtained. And once you finish with one of the checkers, you go to the next. So clearly, the ranking is a way to guide the developers through what we said, the long, complex, iterative process of the performance optimization of embedded C++ code. So this is, so remember, let's start with the technical depth, how many overall. Second, the screening and ranking, particularly what checkers have been found and how many instances of each checker have been found, ordered by priority, higher top-down priority to guide the developer. The third analysis that we recommend is the ROI estimation. Why? Because in order to decide to invest time of your software development team in understanding, implementing, and benchmarking a suggestion of Codee, you need to understand how many hours of development you can potentially save to your team. So the ROI report is intended for that, to give you an estimation of how many hours you will save to your team by using versus not using the automated source code testing capabilities provided by Codee. And of course, the hours and translation into cost savings depends pretty much on the skills of the software development team and different aspects of the organization, like salaries or like working hours per year. So this ROI report can be parameterized, so you can run it and tailor it to the needs of your organization. Okay, so here we have the three, I would say, high-level reports that we typically suggest to get started: technical depth, screening, and ROI. In the demonstration today, you will also see an additional report that we call compiler efficiency. What is compiler efficiency? If you remember, we said that the performance optimization process requires that you write environment-aware C++ code. Environment meaning type of hardware, type of compiler, and compiler version. In this compiler efficiency report, what you will get is a report in the form of a column where you will see the actual optimization opportunities like unrolling, replacement by a system call like memset, vectorization, that was actually reported by your compiler This is one of the columns of the report, and this for each function, each file, and each loop of your code. And also, you will get information about improvements that you can get by using a different setup of the compiler, different flags, or even following and implementing the optimizations or the checkers identified by Codee. Okay? So in one single report and table, you get an understanding of what the compiler has not done with your code and what else you can do in your code at the loop level, at the function level, to go through this optimization iterative process that you need to go through. Okay, so this report is intended mainly for developers to go deeply into the source code. Okay, so here we wanted also to understand, and something you need to think about is, how are you doing your optimization process? Maybe you are not doing anything, maybe you are doing it manually, maybe you are fully relying on the compiler, and compilers and compiler versions have a very different capabilities in terms of performance optimization. Maybe you are relying on profilers, but profilers will not solve the problem. Profilers will just help you to understand which parts of the code are more compute intensive, but will not help you to understand how to optimize the source code of the profiler. Okay, so these are things you need to think about and understanding how you are doing your software development process when it comes to optimization of performance. And based on this, you will understand better where Codee can be positioned in the scope of your software development process. One final thing I would like to quickly go through is to quickly show you that Codee is intended to, is designed from day one to be integrated in CI/CD pipelines. Indeed, while I go through the slides, I will connect to a Jenkins CI/CD framework that we have set up for these demonstrations, where you can see we have set up different projects. I will go into the HiCon project. I will ask the system to build it now and analyze it. You can see how the analysis has begun. This analysis takes around 5 to 7 minutes. So I will leave it running behind the scenes while we go through the slides. So if you are doing automated testing with any other compilers or any other static code analysis tools, you probably have already adopted one CI/CD framework or pipeline. So with Codee, you can see that the output can be, the projects can be analyzed and can be output in different formats. So here you see an example of the Codee screening report that you saw on the screen, but now produced in HTML report, so that you can quickly go through it from a browser and even have links to go to the Open Catalog documentation. Also, you can see that the output of the Codee analysis can be dumped in a JSON format or CSV format or any data exchange format that you can later use as an input for a post-processing tool where you can understand over time or over different releases of your software how different metrics are evolving in your software development process. So Codee also provides JSON, CSV, or any different data exchange formats. Also, here you can see in the screen that in the job of Codee, in a job of your CI/CD pipeline, you can run one or several Codee invocations. In this particular case, we have gone through the sequence of technical debt, checks, ROI report, because here we are assuming that the developers already have done a screening and they know exactly what they need to implement to fix performance issues. Okay? And here you can see that Codee also provides special flags to enable the native and automated integration of the tool in your CI/CD pipelines. So you can run it overnight, on a weekly basis, on a monthly basis, on demand on your release cycles. So it can be tailored to the needs of each software development. Another thing you need to think about is how you are doing your automated testing in your in your projects. It will probably change from one project to another, will change from one software development team to another, but just let you know that Codee can be set up and integrated to check your code for performance on every commit, on every sprint, and every release, or adapt it essentially to the way you are implementing your automated testing in CI/CD frameworks. Okay, so I think I have gone through all the slides that I wanted to present to you to understand what Codee can provide to you, how Codee can help you going through the performance optimization process. And now we would like you to see the tool in action in a live demo. So I will stop sharing. Ulysses, my colleague, will take over the presentation.
So we will use Codee to analyze MBTLS, the same cryptographic library that Manuel mentioned before. And for that, we're going to start with 4 different reports of Codee. We will start with a technical debt report, then we will see the screening, then the return of investment report, ROI, and finally a compiler efficiency report in order to get reports of the difference of optimization levels of the compiler. And then we will proceed to apply Codee recommendations in order to improve the performance of the code. So as we said, we are going to start with the technical debt. Codee technical debt. And we have to pass the path to the compile commands. That is a database of compiler flags for each one of the files of this project. And that's it. It is an output. So now Codee is reading these compile commands and is analyzing all the files that are defined there. In order to generate these compile commands, we only have to add this flag to the CMake invocation, CMake export compile commands equal 1 or on. And this will make the invocation of CMake to generate these compile commands. And if you work with a project that doesn't use CMake, there's no issues because you can also generate the compile commands with third-party tools like Ver for Makefiles, for example. Here we have the result. Here we have the technical dev score. That is the main result that we want to look at. 1,300 of the score. Ideally, this should be 0, or it should decrease over time. So once while the project advances, this number should be decreasing and not increasing. And let's proceed with the screening report. We can change just the subcommand of technical dev with screening. With this report, we'll see a summary of the results of the analysis results of the entire project, because if we list all the checkers of Codee for a project big like this, we will get an overwhelming output. So we need to summarize it before. And this way, we have 1,300 checkers, which are split across these stages. So across these categories, 200 of them are related to memory optimization, 7 to control flow issues, 84 to vectorization. We also provide multi-threading and offloading, but it is disabled as default. And here you can see the ranking of checkers. It is basically, it shows the number of occurrences of each checker, and they are ordered by priority. So the highest priority checkers are on the top. And as always, we leave suggestions at the bottom of the outputs of Codee with the next commands that you can invoke. In this case, we are going to generate the ROI report, which will basically compare two metrics, the time and effort that it would take to perform all the optimizations by hand without the help of Codee, compared to the effort that would take with the help of Codee. And here we can see without Codee would take this amount of hours, with Codee a lot less. And if you are interested in how the formula was calculated, it is explained here below. And you can also change some parameters, for example, the developer cost per year, average hours per year, etc. And we are going to run the fourth report that I was mentioned, the compiler efficiency report, where we can compare two different optimization settings of the compiler, the current one and the suggested one by Codee. In this case, I'm using GCC 11, and with -02, GCC is not reporting any optimization message. But if we change it to -03, as Codee recommends, my GCC start applying optimizations. For example, in this case, it is auto-vectorizing these 3 loops and is applying unrolling to these 2 loops. And while Codee recommends to vectorize all of them. So this is a very useful report in order to, it allows you to see what is happening behind the scenes of the compiler optimizer. Now let's go to the screening report again, but now we are going to focus on reduce the scope of the analysis to the AES.c file, which are the AES encryption algorithms. Here it is, the source file. For example, here we can see the AES script XTX function. And here we can see 9 vectorization checkers. Now we want to see these checkers on screen, 36 checkers in total, 9 of them are of the vectorization category. And we want to see these 36 checkers on screen. We can copy and paste the suggested command. And here we can see them. Again, they are ordered by priority. And now the checks reports allows us to see each checker pinpointing an actual source file and line of code. So here we can see the vectorization opportunities suggested by Codee. And now we will increase the verbosity level of this report in order to get more details for each one of the checkers. And we will see how Codee provides auto fixes. So we used the flag --verbose for this. We will filter out the rest of the checkers that are not related to vectorization. We will focus on the recommendation 53, that is the one that we got here at the top as the most relevant checkers. And here we can see how effectively this output is quite verbose. But Codee is offering 5 auto fixes options. We're going to follow the first one. The first one consists on applying OpenMP pragmas for vectorization, and the rest are for using compiler-specific pragmas for vectorization. So we will apply, for example, this one, and we should see how Codee automatically insert the pragma here. Let's do it again, just in case. Store. We can see how Codee automatically insert 2 comments identifying the timestamp when the write actually happened and the technique applied. This is in order to keep track of the changes that are applied by automatic tools. And here is the pragma insert by Codee. We had to first edit the make file, so we had to add f openmp cmd in this case. And the cmd suffix allows us to use OpenMP vectorization pragmas without actually loading the entire OpenMP library. So this is the throughput result of this algorithm, AES-XTX, with the pragma applied by Codee. And now let's revert the changes. Restore. The pragma is gone. We can recompile. And we will get the results of the original version without the optimization of Codee. Let's say the change here, the result here. So this is the nice. Here we have the original results. So here we can see an improvement of 15% with a single pragma insert by Codee. But of course, as you've seen, Codee suggested a lot of vectorization opportunities for different loops, so you can explore them, and you will probably increase these results even further. This was them. I don't know if you have any questions.
I would like to summarize a bit what we have seen today. So essentially, we have seen in the demonstration that just adding one single pragma has provided a more than 10% performance boost. Like we said, it's typically huge in embedded devices. Here, the demonstration is running on a laptop with a commodity CPU based on x86. So the actual performance gain that you can observe out of this modification will change from one system to another depending on the hardware and the type of processor or microcontroller that you are using in your project. Also, as you have seen in the compiler efficiency report, we now have a clear understanding of what the compiler has done or has not done with every single loop, every single function, the part of the code that we as developers decide to focus on. So we can understand what's going on, and we also get suggestions of what else can the compiler do by itself, or what else can the compiler do with the help of the optimizations or the root checkers detected by Codee. And all of this in one single report. Of course, why this loop providing 10%? This is a trial and error process. This is why we say that performance optimization is not a one-step process. It is an iterative process that you need to go through, and even experts go through this process. They need to understand the whole code, understand where they need to focus on, when they identify the file, the function, or the loop. They need to understand the semantics and what are the potential optimizations that can be applied to the code. And this is exactly in this part where Codee is really helpful through its reports, technical depth, screening, ROI, and compiler efficiency, and checks report with the auto fixes. So we believe that this demonstration is a good demonstration of how Codee can automate the analysis to help you go through the process of optimization of your embedded C++, how it can empower your developers, and how it can enable to simplify this complex, last, and long process that is optimizing the performance of embedded C++ code. So this is the nature of performance, so you need to go through it. So we hope that with tools like Codee, you can see the value in the level of automation that it brings by helping your developers by pinpointing how to implement performance optimization issues and where to implement them. And of course, your developers need to give a try, select, implement, measure time or performance gains properly. This is something that you need to do with and without Codee. So we hope you understood clearly the value of Codee.
First of all, on the demo we just saw, it seemed like all the interface with Codee is done through a text terminal. So my first question is, do you have or do you offer also some kind of GUI which can simplify the usage with the tool, or we need to stick with the terminal-like interface?
Okay, that's a very good question. We provide the command line interface because we have customers that need to connect remotely to a system, need to connect to the embedded system to actually do all go through this process. So command line interface, as I would say, all the bases are essential. Also, we are not willing to support every single IDE or to provide you with a new GUI that you need to learn or integrate into your software development lifecycle. So what we provide is output in serif format, which is a standardized interchange format provided by other static code analysis tools. So Codee can export all the checkers information in serif just by activating a flag --serif or something similar. This is the integration we provide, and serif is supported by VS Code and many other CI/CD pipelines because it's a standardized data exchange format in a static code analysis. I hope this replies the question.
Yeah, I understand.
Yeah.
Another question, if I can, do you also use AI-based or is it only rule-based? The code runs also on the AI, and if it does it run on cloud or is it on-premise?
Okay, very good question. We get this question very, very often today with these tools of generative AI and AI for developers promising to revolutionize the software development process. Codee is not AI-based. Codee is, as you call it, rule-based. So we use our own technology, Codee, that is not using AI. It is not using any large language model or similar technology inside the tool. The reason for doing so is that we are working with our current customers and partners because they want to understand how to integrate Codee in Dev AI tools, or how can Codee complement the capabilities of Dev AI tools. Let me show you an example of an ongoing project. If we pick up one code large language model and we pass it through the code and ask it to report what performance optimizations you can do on the code, you will probably get a report saying what optimizations you can do. And if you ask it to rewrite the code, it will probably rewrite the code for you. But there is no promise that the code generated by an LLM will be correct. And in safety critical, in embedded software development where correctness is key and it's a hard requirement before any performance optimization issue, the hallucination effect of large language models is a huge pain for the adoption of these tools. But it's good to recognize that LLMs are great in the sense that you can interact with them using natural language instead of having to use tools, set up tools, and understand the output of tools like Codee. So what we are trying to work with our partners and customers to understand how we could benefit from, I would say, the best of both worlds. So interaction in natural language with LLMs, and also use Codee, strictness, and technology that verifies and guarantees correctness. Of course, some false positives can be there, some bugs as any software has, but our philosophy is to have less than 5% false positives in everything we report. That is our aim by design. So our customers are understanding how Codee can be used to actually verify the output generated by the LLMs. This is a use case. Other use case can be also integrating Codee inside the LLM architecture so that you don't have to use Codee, but the LLM output will be automatically behind the scenes verified using a tool by Codee or even verified with a target compiler. But of course, this is all, I would say, kind of applied research as of today. So we understand that Codee value is guaranteeing correctness using a command line interface and output in serif format as any other standard static code analysis tools. And of course, we are also taking an eye on the evolution of Dev AI tools and large language models to take the best of both worlds to provide a whole solution. So
I think in the Q&A chat there are some more questions.
So if I go through them, another question is, the demo was on x86. However, medical devices are often ARM-based and even with RTOs. How about working with cross compilers and even SND OpenMP are not available? Okay, so we have results of embed-TLS being accelerated in a similar manner on ARM architecture. So let me show you. You can see the screen, right?
Yes.
Okay, this is We have picked up here recommendation 43, a different one we have not seen today in the demonstration. And we have selected a code where you can see that both on x86 and ARM, by using and implementing exactly the same recommendation of Codee, you get faster code. But of course, how much faster the code runs depends on the actual hardware, as you point out. So here you can see that on x86 you get 3x faster code, and on ARM you get almost 2x faster code. Related to cross-compiler questions, this is definitely a very good question, because Codee, you have seen the demonstration of Codee in the default mode, that is running and interoperating with the native compiler you have installed in your development environment, in your development laptop. But also we have developed Codee capabilities to interoperate with cross-compilers. Cross-compilers are another level of complexity, because you need to understand what will happen in a system that is different from the system where you are actually developing the software. So we are developing new capabilities, but we already have capabilities to show similar results in cross-compilation environments. Related to auto fixes and how to implement vectorization, we see a trend in embedded development and even in cross-compiler environments to trust GCC or LLVM compilers, and even more and more recent versions. We typically used to see GCC 7 or GCC 8, but now we see in some environments GCC 12, 11, 12, 13, we even see LLVM 16. So in these more modern compilers, OpenMP is supported natively in the compilers. And OpenMP, you can consider it just another option, an alternative to compiler native SIMD pragmas. Okay, so it's just a way to specify how and where to vectorize loops. It doesn't add any complexity or any link time and any link with any runtime of OpenMP when you stick and you only focus on SIMD and vectorization. So the short question would be, we support ARM. Of course, from ARM M to ARM series R, A, or X, there is a wide variety of hardware capabilities that we need to understand better. So ARM in general is supported properly by Codee. And also when it comes to vectorization, OpenMP is supporting modern versions of GCC and LLVM compilers. And if it is not available, or if it is a restriction for you, you can resort to SIMD manual implementations or to SIMD native GCC or LLVM compiler flags. We provide the CLI interface because it's the basis for usage on the terminal, usage on the CI/CD pipelines, and to connect it with the IDEs like VS Code, we provide Serif output. And the final question is, as the modification is done by a pragma and not actual change of the C code, how sure are we the functionality is correctly maintained? Not sure what you mean by correctly maintained, but whenever Codee reports a recommendation like 53, a new SIMD or vectorization opportunity, Codee guarantees that the recommendation is applicable, that the loop is vectorizable. And it also guarantees that the implementation of the pragma is correct. So here we have seen an example of a recommendation. Let me go back to the Open Catalog. We have seen the recommendation 53, for instance, which is about adding a simple pragma for vectorization, explicit vectorization of a loop. But also we have other rules like, for example, 54, where you have something a bit more complicated that requires additional clauses or decoration of the pragma, like specifying that it is a reduction operation. So all of these semantics about the behavior of the code are recognized, detected by Codee. So when Codee adds the pragma, it guarantees correctness by taking advantage of understanding exactly what is the semantics of the code and what the code is doing from the code patterns perspective. I hope this is what you intended in your question of how are we sure that the functionality is correctly maintained. I hope this replies to your question.
Yes, it does. Thank you.
Okay. Anyway, if thank you very much to everybody. If you have other questions later, or if you want to know more, just please come back to us, either to Codee. You find them easily on the web, codee.com or verifysoft.com, and you can contact us and we will answer your question. Thank you very much, and yeah, have a nice day to everybody. Thank you very much. Bye-bye.
Thank you very much. Bye-bye.
Thank you. Goodbye.